As time moves on, cities are constantly looking for ways to bring life and culture onto their streets. The current most popular way is by painting large building murals. These murals can be expensive, complex, time-consuming, and painting at heights can be dangerous. This is where Robo Picasso comes in. Robo Picasso is a robotic arm on a cable-based platform that can emulate the movements of a human artist. This robotic system assists people in making art, specifically to recreate and scale up art designs. Robo Picasso consists of two major parts, the robotic arm and the cable system. The cable system allows the arm to translate in the X and Y directions on a variety of building or wall sizes. The robotic arm is designed to rotate with multiple degrees of freedom to allow for various painting stroke patterns, widths, and orientations. The robotic arm has a detachable brush to allow the artist to change the configuration depending on their needs. It also includes a built-in paint container for dipping as a human artist would. The engineering process for Robo Picasso was not without its challenges. The team ran into some issues when creating prototypes. One of the first issues encountered was ensuring that the motors did not stall under use. This was done by looking at the heaviest components, the servo motors, and calculating a torque balance with the length of the entire arm. From this calculation, it was found that there were some configurations that would cause the motor at the base joint to stall. This led the team to include 2 servo motors on the base joint instead of 1. The team also performed a backlash analysis of the robotic assembly, which is an analysis of the tolerance of the paintbrush position. From this, it was found that the position tolerance due to backlash is less than half the brush size, which was well within tolerance. The final issue was singularity conditions. This deals with how the robot moves in space. Unlike a human arm, the robot can bend its elbow backward, which puts the arm in some uniquely difficult situations. The solution to this comes down to kinetic motion planning. In the software, these situations are identified when the robot is approaching them, and a different motion path is chosen. What makes Robo Picasso different is that it has a 3-degree of freedom arm, which mimics an artist's movements, such as dipping the paintbrush into the paint container, painting without leaving the canvas, and reproducing different strokes. 6 servos, each with 3 degrees of resolution, are used to move the arm and brush with high torque and precision. The base also acts as a damper, which increases the accuracy and speed of painting by reducing shake and other instabilities. A typical artist is generally capable of completing 1 mural every 1 to 2 weeks. Robo Picasso can paint 624 square feet in an artist's standard 8-hour workday. This comes out to be about 3 murals a day. In addition to enhanced performance, safety is also greatly improved as manual labor is avoided at dangerous heights. Furthermore, the overall cost of prototyping the Robo Picasso project came out to be $490, and according to expert opinion and market comparisons, Robo Picasso could be produced and sold for $3,000 per unit, which is comparable in price to commissioning just a single mural. In conclusion, the Robo Picasso product addresses very important factors such as cost and safety. Through many design considerations and engineering analysis, a robotic arm was created with multiple degrees of freedom and low amounts of backlash. This design allows for great accuracy in large-scale painting projects while significantly lowering the project cost and time and improving the safety of work. With Robo Picasso, the possibilities of large-scale murals are limitless.